Live. Okay, today's date is November 3rd. So our objectives today is really to manipulate logarithm and exponential expressions. Right?
Got very quiet.
Brittany left. Brittany's so quiet as it is. So, we kind of know, we've been doing exponential form, right? So this is a little shortcut to make it easier for you, but I'm going to highlight the words first. So, if it's an exponential form, then, for example, you look at this example, e to the x, the unknown or the exponent is in the x, okay? That's exponential, okay? So what we have here is answer equals base to an exponent, okay? So that's, as an example, I'm going to give you an example. I'm going to give you 10 to the x equals 351, right? That's our example we started with today in our calculator, right? Well, we can change this into a logarithm. So what we're going to do is we're going to change this into a logarithm. It says log of the base of the exponent of the answer equals the exponent. Log. So log is just the word log. It means your calculator is going to take a logarithm. The log word is just what your calculator does. So it's a log of the base. So in our example, the base is 10. You see this? So we're going to rewrite this as log. Our base is 10. It's base 10 of the answer. That's my 351. Equals the exponent, which is the x. Okay, so I moved it from exponential form to log form. Make sure you know what I did. This is the important stuff, okay? This is the important stuff. Today, right now, you've got to get this because I'm going to move on. If you don't get this, stop me. Okay, let's do it one more time. Okay, I've got 10. That's my base. 10 to the x. That's my exponent, right? 10 to the x. That's my base. So I go log of the base. Put the 10 down here. So it's a subscript number. Of the answer, okay, of the answer, okay, so I'm going to rewrite the 351 here, equals the exponent, so my exponent was the x. See that? And then I can use my calculator. Now, on your calculator, it doesn't say 10, does it?
No.
So, it just says log. So when you see just log, it's called our common log. So common log is base 10. And that's what most calculators are going to do is base 10 because we live in a base 10 world. So you don't see a base here, but it's right by 10 to the x. If you look at your calculator, it's right by 10 to the x, which makes sense. 10 to the x and log base 10 are inverses of each other. How am I doing? Okay. So then what I did is I just did a little, kind of a little shortcut, so I didn't have to write the words, but answer equals base of the exponent, rewrite it, log of the base of the answer equals that. Same thing, but it's without using words, it's using the symbols. Answer, base to the exponent, log of the base of the answer equals the exponent. So the same thing, but I just wrote it using symbols, so I don't have to write it all out each time. Okay, so this is just it's kind of like our, our rule. This is our rule here, but it's subscript, okay? So, let's take a look then at example 1. Okay, so first of all, change it to exponential form. So we're going to go from this form to this form, okay? So I'm going to go, all right, I'm going to rewrite it as the answer. The answer is 81 equals our base, that's our 3, to our exponent. Or I like it this way, 3 to the x equals 81, okay? So it's see if I can get this so you see it.
Oh, so ln's base e.
You're ahead of me, as always. Good.
Sorry.
Thank you. Awesome. Thank you. You're totally right. So it's just 3 to the x power equals 81. See it again? 3 to the x equals 81. That's all we're doing. Thumbs up. Taking this number, the base, 3 to the x power equals 81. Okay? Boom. Now, ln is base e. So I'm going to rewrite this. Okay? So natural log, we have a common log, and then we have a natural log. And that is log base e. But we don't write as log base e. We write as ln, which you think is log that is natural. I don't know. I just teach, okay? I don't know how to... Anyway, ln means natural log, which means base. So when you see this, when you see ln, it really means this. These two are the same, okay? But you won't see the e. So even on my calculator, I see an ln, right? And this ln means log base e, okay? This means log base e, okay? The e is invisible. So I'm going to rewrite this in b as log base e of 2 equals x, okay? And if I want to rewrite it in exponential form, I'll go e to the x equals 2. I'm going to go e, the base, e to the x equals 2. That's all. Okay, give me thumbs up or sideways. I really want to know, because it's super important that we see what I'm doing, okay? Can you transpose it? That's the most important thing. I really can't go forward unless you see how this works. Okay, I went this e to the x power equals, what's inside the answer? Okay, that's all I did. I went 3 to the x equals 81. That's all I did, okay? Thumbs up on that? Okay, good. If you got that, then the rest of this is going to be easy. If you lost that, then we're in trouble, okay? Now, example 2, we're going to have the opposite, okay? So the opposite is we need to write as a log. So I'm going to go log. What's my base? 10. That's my base. So it's a subscript number, base 10 of 1,000 equals x. That's it. It's the base, log base 10 of 1,000 equals x, okay? Got it? Kai?
So for the next one, B, would you do log e 2 equals x, or would you just do ln?
So let's change it to exponential. So yeah, so if we want to change it to exponential, we're going to go e. So I agree with you. We're going to go e to the 2. Why did I write log base e? Why did I do this? I need a base, right? What is the base here? Base e. Okay, I need a base. I got my base e. So I'm going to go e to the 2 equals x, okay? Okay, now, example, I guess it'd be example 3a. So find the value of the line. So what I like to do is just set it equal to x, okay? Now you have log base 10, but you don't have log base 2, do you? But we could do this. We can use our brains. We can. We can go 2 to the x equals 32, okay? All right, come on, smart kids. 2 to the x. What would x have to be? 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So x has to equal 5. 2 to the 5th power. Check it out. I can do that on my calculator. Okay, then 2 to the 5th power, 32. Awesome. Good. Okay, how about b? Well, I'm going to set it equal to x. Yeah, what's the base? It's invisible. What's the base? 10, right? It's invisible. So it's 10 to the x equals 100, right? 10 to the x equals 100. What's x have to equal? 2. X equals 2, and sure enough, we can check on our calculator. Okay, what is 10 to the 2 power? I know that's 100. I don't need help with that. Of course. So let's rewrite this as, it's a little tricky, but we can do it log base e of e, and let's set it equal to x, okay? Okay, so ln, I need a base. It doesn't show a base, I need a base. It shows e, but doesn't show a base. What's the base? E. Okay, let's go e to the x equals e, right? E to the x equals e. Don't let it trick you. What's x equal?
1.
Good. It's got to be 1. You guys agree? X has to be 1. Nice job. How am I doing? Seem easy so far?
Yeah, it's too easy.
Good. Yeah, I told you logarithms are not hard.
It's too easy.
Yep. Okay, turn the page. Okay, now. Set it equal to x. Okay. And what are we going to do? Anybody have? See if you guys can get this one. See if you can get this one. Try it. Just try it. And if you don't get it right, that's okay. Give it a try. See if anybody gets the answer. Candy to the first one who gets it right. Okay, so I'm going to go 5 to the x equals 1 over 25. Now, if I can make them the same base, that's easy. So 25, that's got to be a 5 number, right? Isn't 25 a 5 number? What is it? Yeah, you're ahead of me. Yes. So 1 over 5 squared. And then Lauren said, you bring it up, right? 5 to the x equals 5 to the negative 2. So this expression is equal to negative 2. Yeah, okay. Okay. E.
Would the root be inside of the parentheses if it was the logarithm, or would it be outside?
The
would
root's
it be
outside. Yeah, the
outside?
root's, it's log base 5 of the fifth root of 5. Anybody got an answer yet? Got one more piece of candy. It's okay if you don't get it right. I mean, it's just good to think. Isn't it good to think? It's like getting in the weight room, right, Kai?
0?
Close.
Ah.
1. No.
Is it 5?
5.
Closer.
1/5.
Little cheater. There you go. Thank Vince for that, huh? Nice job. Stole it from you, huh? Let's see why it's 1/5, okay? So it's 5 to the x equals the fifth root of 5. But that's the same thing as 5 to the 1/5 power, right? Right? Vince, you had it, didn't you? She stole it from you, didn't she? What a gremlin. X equals 1/5. There you go. Nice job, Carly. Okay, how about F? How about F? I might have another piece of candy for this one. I think I got more candy for this one. Carly, it's great. What about this one? But you're close. You got it good. Now you're just thinking, huh? Nope. Hold on. The last time you guessed, it paid off, didn't it? Right. So it's okay to guess, right? Whoa, dude! Say it again. -3. Yeah. Yeah. So invisible base 10, right? You guys agree with that? So it's 10 to the x equals 0.001. 10 to the x equals this, right? So I know that 10 to the negative 1 is 0.1. 10 to the negative 2 is 0.001. And Ethan, 10 to the negative 2 is, negative 3 is 0.0001. Nice job. Oops, I got one too many in there, okay? You got too many zeros here too. Doggone me. Anyway, there you go. Yeah. Nice job, Ethan. Negative 3. Okay, good. Okay, now, what about G? I got lots of candy, so what the heck? I got lots of candy.
X equals 0?
Oh, Lauren, that was so fast. Okay, hold on, I got candy. Okay, x equals 0. Okay, why?
Because it's 3 to the x power n equals 1.
We know anything to the 0 power is always 1. Nice job, Lauren. You guys agree with 0? 3 to the, okay, so check it out. 3 to the x, so 3 to the x equals 1, but we know that 3 to the 0 power has to be 1 because anything to the 0 power is 1. So x equals 0. Nice job, Lauren. Okay. How about this one? Okay, here's what I'm hearing. I'm hearing 4 to the x equals 4 to the 3. Well, that one's pretty easy. That's not worth candy. Everybody see it's got to be 3?
Yeah.
Yeah. Okay. How about I? So what did you say?
Oh, I did 4 to the 3rd and then I was. Yeah,
Oh, you did that one too, right?
This is easier that one.
Yeah. Is that what?
Negative
It says error. It's undefined.
Why is it impossible?
Because you can't, nothing to, or you
Nothing
can't,
to-
nothing to the power of
Nothing with a
10 would be,
value can equal
nothing
the power.
10.
Right? I mean, if you take 10 to a negative power, it just becomes a decimal. 10 to even a bigger power is still just a decimal.
Yeah, you
10 to even bigger number is still just a decimal. But a decimal is like getting small, so it never gets to 0, does it? In fact, try log. Just try log of 0.
And it goes error.
Goes error, right? So that's undefined. So then what about this one? Try that one on your calculator. So then this is undefined. No solution. Oh, I'm sorry, I'm ahead of you. No solution.
How do you do log base 2 in UK?
Oh, try log base 10. It'll be the same answer. So here's what, if I were to graph, even log base 10, I want to graph it for you. Y equals,
Zero.
log of x.
1, 2,
Let me see, I might have to set my window more correctly.
Unless it's.
All right.
Which there is no log base 0. Is there? Mr. Davis,
What?
is there a log base 0?
No, there is not. Great, really good question. I don't think anybody's asked that question for many years. Good question. Yeah. Because you can't have a 0 to the 0.
Yep.
Right, okay, so then if we graph this, let me get a decent window on this. I'm going to go, let's see, 0 to, let's go 10. And from 0 to, say, 2 and graph this. And what you don't see is the decimal part. So it looks like this. Okay, that's y equals log of any base to the x. And this is y equals some base to the x, okay? And we've talked about inverses. You can see they are inverses of each other. They are inverses of each other. So the domain, x is greater than 0. Not equal to, but greater than 0. So we have what we call an asymptote. And have we talked about asymptotes in here yet? Okay, you guys have heard that word, right? So you have a vertical asymptote for the logarithm, and you have a horizontal asymptote for the exponential. But if they're inverses, that makes sense, doesn't it? You've got a x equals, and then you get a y equals 0 for your asymptotes. Okay, so that's it. Doesn't that seem pretty easy for you today? Lots of time, which is nice to get some stuff done.